Hey, how's it going? This is Felix, and today I'm showing you how to use Iguana to benchmark your Triplestore. So let's dive right into it. First off, let's make a working directory. Let's call it Iguana. Go into it. Clear. Then we need the Iguana file, so let's go to github, https, github.com, dice group, Iguana. So what we want is we go to the releases and we want from the latest release this release zip. So copy link location, we get paste. This may take a few seconds. Awfully slow today. Well, let's just ignore it. I already downloaded it, so no. Iguana, yes. Yeah. Let's just pretend I downloaded it. It's the same zip file, so yeah. What we have is a zip file, so unzip it and clean up. Go into the zip file. So let's clear again. Let's look what's in it. We have 6 files. 2 represent Iguana itself, 2 are basically just configuration properties, and 2 scripts. Let's make the start Iguana script executable using gmod +x start Iguana. Not sure why it's not, but yeah, executable now. So let's look at it again. We have the core controller and the result processor. The core controller basically executes a benchmark against a Triplestore. It executes every query you define in your benchmark and will collect the time it took and if it succeeded or if it failed due to like a timeout or an HTTP error or whatever. This information then will be sent to the Iguana result processor through rabbitmq. The result processor module will then collect all those executions and calculate metrics like queries per second, query mix per hour, etc. out of it. Basically, which metrics we have to say it should save is defined in the RP properties. Let's look at the configurations first. The core, it just defines the rabbitmq host we want to use, as we use rabbitmq for the communication between those two modules. It's localhost, it's normally localhost, so you don't have to change that. Let's clear it up. Look in the RP properties, bit more meaty again. Localhost, rabbitmq, you can ignore that basically. Afterwards we have the 2 more important lines are the Iguana RP metrics and the Iguana RP storages. Iguana RP metrics uses QMPH, QPS, and NoQPH, which are defined here using the class parameter. Basically, these are all the implemented Iguana metrics. Basically, you normally use query mix per hour, queries per second, and number of queries per hour. For the storage, it basically says how we want to save the results, and we use an ntriple file for that. We could also use a Triplestore, but we don't do it here, so just so you know, there's the option to it. Let's clear this, and let's look at the let's first of all minimize that, and let's look at the shell scripts. First of all, we have some config. As soon as these 2 models are started as daemonized processes, we can send Iguana benchmark configuration to the core controller, which then will execute the benchmark. So this is not that interesting. This is a little bit more interesting. Let's look into it. It has 2 lines. It starts the core controller using the core properties as a daemonized process, and it executes a result processor module using the RP properties as a daemon-sized process. And see, good we looked into it because it has a different version number. Let's change that quickly. Always make sure it's correct. It was 2.1.0, not 2.1.1, so Great. Let's check again. Cat start Iguana. Great, working. So before we can start Iguana, we have to install and start rabbitmq. So let's open up a new window and go into Iguana. Start. No, first we have to install it. I already have installed it, so won't take much long. But let's look at it. Rabbitmq -server. So sudo apd get install rabbitmq server. Password. Yeah, it's already installed, so let's kiss up. Just in case it started, I kill it. So you see it's going. So now we can start it using sudo rabbitmq -server. Takes a few seconds, I guess. I'm working on a VM, so might be a little slow. There it has. It's loaded. It started. Sorry, not loaded. So let's go into our previous window. First off, let's make another window and another window. So cd iguana and cd iguana. So now we can start. Sorry. There. Now we can start Iguana. Yeah, it's started and we can use it now. But before we can use it, we need a Triplestore we want to benchmark. So let's go here and let's download Apache fuseki. Yeah, Jena apache.org. Go to download. We need the Apache Jena gz and the fuseki gz. So discover link location we get placed. Now the internet connection is good. I don't know what's wrong with it today, but doesn't matter. Again, the fuseki we get. And great. While it's downloading, let's explain it. This one is actually the database, a TDB RDF database, which then will be used in the fuseki web server. So we need both. This is a web server, and this is basically the database. So it's downloaded. Let's close up. Yeah. tar -xz vf Apache Jena fuseki. Yeah, that's okay. And Apache Jena 3.13.1. Let's clean up again. Tar gz clear. Okay, so let's go. Well, we don't have to go into it. We can call it from here. Apache Jena. Nope. /Apache Jena 3.13.1 /bin no, TDB loader 2. If you're using Windows, use TDB loader. TDB loader 2 won't work, so afterwards we have to define a location we want to save it. Let's use just current directory and subdirectory ds and the file we want to use. I prepared a dataset called dataset nt. I will show it in a minute, but let's load it first. There it is. Let's look. Let's clear this up. Let's look at the dataset. Basically, it's just a little bit gibberish, nothing really important, just some random shit. So, yeah. Let's start fuseki by going into Apache and fuseki. Close up, because why not? And started with the current fuseki server, --log. Again, the location, it's one path above us in DS, yes. And we have to use a web path. Let's say it is /ds. Remember it. Yeah, that's it. Let's demonize it. Just why not? So I can't kill it accidentally. That is started. Great. Let's go into this one. Clear. Hope I get the correct Python import. urllib. This is basically just to test if the dataset was really loaded. You should always do that, even though you think it is. Just do it. It will save you a lot of work if it is not safe. Believe me. Slash and urllib parse, and I think it's scroll plus, and then we have select star, simplest sparql query I can think of. Has no object because it's probably Python 3. Let's use, first of all, let's use print. Still no urllib. Okay, I don't know the comment currently, so let's just go to urllib encoder. Faster that way. SPO. Yes. Encode. Let's copy it, and we can minimize it for now. And let's look at it. Curl -x get. Probably don't have to use -x get, but let's use quotes. http/localhost 3030 is the port, right? Yes, 3030 /ds, our previously mentioned path, and sparql query equals, and then our query. Perfect. As you can see, that was not what I wanted to do. There. There. As you can see, the dataset is fully loaded. Perfect. Probably you have a bigger dataset, just use count or anything else. So let's close up. Alright, let's make this. Nope. Let's make it. Yeah. Sorry. Let's. Always touching the wrong. It's new keyword. I'm sorry. Let's make this panel a little bit bigger. Okay, great. So we have started fuseki. We have started Iguana. So now we have to create a benchmark configuration, which we can then send to Iguana core controller, which then will execute the benchmark against fuseki. There is a basic configuration in the Iguana GitHub, so let's use it. It's called Iguana basic config. Go to raw, just copy paste it or download it, whatever you want. Let's make this a little bit bigger so you see what's happening. Nano iguana.config. Paste it, and I will guide you a little bit through the config. The first block is basically the Triplestore we want to use. So we define our connection 1. You can name this whatever you want. It just has to be the same for all those 5 lines, and you have to change it here as well. But for now, let's use connection 1. Let's name the Triplestore fuseki, and the service, the endpoint service, also not correct. It's at 3030 ds/sparql. Our update endpoint, as we don't use updates in this tutorial, we don't have to change it, but just do it either way. So again, 3030-ds/sparql. We don't have a user, we don't have a password. That's working without authentication. So in Iguana CC connection, we define all the Triplestores we want to test. So connection 1, and if you have another connection defined as this, let's say it's called Virtuoso, we can name it Virtuoso and put it in here, and it will be tested too. But as we don't have that, let's remove that again. So as we have several data sets, we have to define that as well. Again, it's just a name in this case. Let's use dataset, very imaginative, I know. And in Iguana CC datasets, again, we have to put in this little name, dataset 1. If you have several datasets, just put it again, dataset 2, dataset 2 name equals whatever. Okay, don't need it now, and we can remove that too. So now to the actually benchmark task. Basically, you can you don't have to change really much from here. Basically, we have an object, a task, which is defined with a class parameter, stress test.class, and stress test constructor args down here. Again, this is just a name we add. You could also call it task 0, task 1, whatever you want. Just put it here, change it here, again. And we use the stress test implementation of Iguana itself, and basically this has the following constructor arguments down here. We have time limit and end restriction. Basically, we have a query handler, and we have a query pool, which called worker in here, and we have a warm-up time, and it's not showing. Let me show it to you. A warm-up time and warm-up queries as well as warm-up updates, and we defined it as stress test arg.timelimit for the end restriction. This is right here. So we set it here to 1 hour. Let's not do this. Let's use 10 seconds. That's enough to show you how it works. We could also add a certain amount of number of query mixes, which are executed, for example, 1000. Again, let's not do this. Let's just use 10 seconds. This is in milliseconds, obviously. So next thing is warm-up. Again, stress test arg, warm-up time. We don't want to use warm-up, so let's set it to 0. And warm-up queries and warm-up updates, yeah, well, nothing basically, as we don't use the warm-up. If you have warm-up time, you don't need to set either of them. Just set one of them if you only want to warm up with queries or with updates. If you want both, you can define both. Yeah. Now for the meteor part, we have the user pools. So sparql, the stress test arg workers. Basically, this is just like several user pool configurations. One of them is defined here, sparql config run. In which case we have 16 simulated users. Let's not do this because I'm on a virtual machine, so just let's use 4. That should be sufficient. We have the implementation of Iguana for the sparql worker, which is basically, it's basically just a simulated user which executes all queries in a row. Nothing more, and we simulate 4 of them. So further on we need a query timeout. This is defined here. 180,000 milliseconds represents 3 minutes. And we need a queries file. Good, it's stated a tilt here because tilts are not working. You have to use an absolute path, for example, temp/queries.txt. We have to create this queries.txt at temp later on, but for now, let's go on. We have 2 zeros here. They are just for simulating network latency. If you want to simulate network latency, please look at the wiki. It is defined there how you can use that. The next thing we have to do, let's make some space here, is to set this user pools. So if we want to have several user pools, we could basically use several one. Let's call it sparql config 2. Let's use 14 users and basically another queries file, for example. Sorry, queries2.txt, and we could just edit sparql config 2 for the user pools. So we don't use it. Again, I'm on a virtual machine, don't want to stress this too much. So let's remove this too. We now have our warm-up defined, our end restriction defined, our user pool defined, and we want to define our query handler. Basically, the query handler is will check out all these queries and basically put them to the users. Not sure how to explain that. Basically, we have 2 query handlers implemented, the instances query handler and the pattern query handler, and the instance query handler assumes that in this file are only valid sparql queries and nothing else. Using the pattern query handler, you can also use pattern queries like select star s, and let's use a var. And oh, this is not a valid sparql query, but it uses a pattern var1. And if you want to have do's with valid data in it, for example, RDFs type, OVL type, whatever, you can define another reference endpoint, and it will fill this pattern with actual data, and then you can define like a limit. You want to have 2,000 queries of these, so it will generate 2,000 query instances out of this pattern, filling these vars. If you want to use them, please look at the wiki. Let's remove that, and for now we use only instances, so valid sparql queries. The pattern queries are from the dbpedia sparql benchmark of 2011 or 2012, not sure right now. If you want to dive further into it, please look at the paper there. Last thing we have to do again is to add this to the constructor arguments, so stress test arg time limit defined here, our end restriction, our query handler, our user pools, etc, etc. We don't have to change it if you use this basic configuration and just change it to your needs. And finally, there's like Iguana CC task, which defines or basically states which task we want to use. In this case, our stress test defined here and here. If you have another task defined, just add it again, stress test 2 or task 0 or whatever you call it. Basically, that's it. Let's just look at what we changed. We changed basically the connection name, the connection endpoint. Okay, we changed the update endpoint. In our case, it wasn't necessary. We changed the dataset name. We changed our time limit because we don't want to use 1 hour. And we changed our queries path as well as the simulated user. Sorry, that's it. We didn't change anything more. So let's save it. And there we have our configuration. Great. Let's minimize that again. And let's check again. We have rabbitmq running, we have Iguana running, we have our Triplestore we want to test running. Let's check if it's still running, just in case. Great. Cool. Still working. Then just let's send us the results. Not in the correct folder. Let's change into Iguana release. There's a send config. Send config. Iguana. Oh, we have to copy the queries to the temp folder, as we stated in the Iguana config. Let's first root the config in our working folder. Nope. Sorry. One path above. Iguana config to here. And I previously made some queries. Let's look at them. Basically, these two queries, nothing special. But let's use them. Queries.txt to temp queries.txt as we stated in the Iguana config benchmark configuration file. Sorry. So let's send configuration. And let's make this window a little bit smaller. Config. Finished, and it's starting. And great, it worked. Let's wait for the end results. 10 seconds, yeah. So what we have is this little number. It represents our experiment task ID. Basically, this is very interesting for us because we have now a file called results, and then your like date and hour you executed it. So let's look into it. Let's make a new window, to be honest. Yeah. So cd Iguana release cat results, and as you can see, this is an Entropy file, rather big, and you could directly upload this to Triplestore and query it using sparql, and I'll recommend that because there's a little bug. I show you the bug later, but now if you want to see fast results, let's like use cat results and use grep, for example, queries per second. And here we have it. Now we have for each of the simulated users sparql, this first sparql query, and the second sparql query, the queries per second. For example, the first simulated user about 7 QPS for the first sparql query and about 5 QPS for the second. And you can see the second sparql worker had about 6 and 4. The third had about 7.3 and 4.3, and so on. If you want to have like an overall result, just add like, for example, for sparql, for the first sparql query, just add all dues. Let's use another grep, sparql 0. So just add all dues values up, and you get the overall QPS for sparql 0. Now I'm showing you the bug I mentioned. Let's use cat results and grep. It's number of queries per hour, our other metrics. And as you can see, it shouldn't have 8 results, it should have 4, and it's because this is a complete duplicate of these 4 lines. If you put it into a Triplestore, it will have only 4 of them, depending on the Triplestore implementation, but normally it shouldn't have duplicates on it. It's kind of thing of RDF, to be honest. So if you want an overall result, just add them all up again, because these are this for the fourth worker, third worker, second worker, and first worker. So first sparql user, if you want to. And yeah, that's basically it. And I hope you learned how to use Iguana today, and see you next time. Have a nice day. Have fun benchmarking. Bye.